We're going to solve a few more examples on the cross product of two vectors, and then we will talk about or we will start discussing a review of differential and integral calculus. Okay, so the first question, given m vector is 2i hat minus 3j hat plus k hat, and n vector is 4i hat plus 5j hat minus 2k hat, calculate the vector product m cross n. Now you will remember we calculate the resultant vector r, that is the vector cross product or vector cross product of m cross n by calculating this determinant. So this determinant of I hat, j hat, k hat, our unit vectors on x, y, and z axes respectively. Then we write the components of m in the second row, 2, minus 3, and 1, and components of the second vector, 4, 5j hat, minus 2k hat. So we form this determinant. And we're going to take this determinant with respect to the first row, so we will have plus, minus, plus. And for the I hat component, what we will do is we're going to cross out the first row and the first column. So we cross out the first row and the first column, and this is going to give us the product of minus 3 and minus 2 minus the product of 5 and 1. So we will have minus 3, minus 2, 5 and 1 subtracted. So this is going to give us, because it's plus I hat times minus 3, minus 2, minus the product of 5 and 1, 5 and 1. And for the second row, for minus j hat component, we're going to cross out the first row and the second column. Then we will have 2 and minus 2, 4 and 1. So this is going to give us minus j hat times, we look at the blue ones, minus 2 and 2, so it's minus 2 times 2 minus 4 times 1. And for the k hat component, we cross out the first row and the third column. Then we will have 2 and 5, 4 and minus 3, so 2 and 5, 4 and minus 3. This will give us plus k hat times 2 times 5 minus 3 times 4. So this will give us I hat times 6 minus 3 times minus 2 is 6, minus 5, and minus j hat minus 2 times 2 minus 4 times 1 minus 4, and plus k hat 2 times 5, 10, minus 3 times 4 minus 12 minus becomes plus 12. So we see that the r vector is m cross n, the resultant vector m cross n is going to be 6 minus 5, which is plus I hat, minus 4 minus 8, there's another minus, becomes plus 8 j hat, and plus 22 k hat. So this is our answer for m cross n. Okay, so for clarity, purpose of clarity, let me show what I have done here in 3 steps in this determinant, calculating this determinant. We have I hat, j hat, k hat. The first calculation is done for I hat, 2 minus 3, 1, 4, 5 minus 2. The first thing I did was cross out the first row and the first column, and then I calculated the product of minus 2 with minus 3 and subtracted from it 5 times 1. So this was the first step. Then I worked on minus j hat. So this is I hat, j hat is minus k hat, 2 minus 3, 1, 4, 5 minus 2. So I crossed out the first row and the second column, and then I calculated 2 times minus 2 and subtracted from it 4 times 1. And in the third step, I calculated the contribution from k hat, I hat, j hat, k hat will be positive k hat, 2 minus 3, 1, 4, 5 minus 2. I crossed the first row and the third column, and I looked at the product 2 times 5 and 4 times minus 3 was subtracted from 2 times 5. So this was first step, second step, and third step in the calculation of this determinant. Okay, and the other thing I want to note here is if you have the cross product of the unit vectors I hat, j hat, and k hat, I want to remind you that if you go in the clockwise direction, this is the positive direction, so that I hat cross j hat is k hat, j hat cross k hat is I hat, and k hat cross I hat is j hat. If you go in the opposite direction, let's go in the opposite direction, which is counterclockwise. This is the negative direction. So we have I hat cross k hat is minus j hat, k hat cross j hat is minus I hat, and j hat cross I hat is minus k hat. This is basically following cyclic permutations. Okay, now let's move on to another example. Two vectors are given by these expressions. A is equal to minus 3i hat plus 7j hat minus 4k hat, and B is 6i hat minus 10j hat plus 9k hat. Evaluate the quantities cosine inverse of dot product of A and B divided by the product of the magnitudes, sine inverse of magnitude of A cross B divided by the product of the magnitudes, and part C asks which gives the angle between the two vectors. So let's start with part A. Well, the dot product between two vectors A and B is given in terms of their components ax bx plus ay by plus az bz. So x component of A was minus 3, x component of B was 6, so minus 3 times 6 plus y component of A is 7 multiplied with minus 10 y component of B, and z component of A is minus 4 multiplied with y component of B, which is 9. So the dot product becomes A dot B is equal to minus 3 times 6 is minus 18, 7 times minus 10 is minus 70, and minus 4 times 9 is minus 36, which is minus 124. Now the magnitude of vector A is square root of 3 square 9, 7 square 49, 4 square 16, which gives us magnitude of A to be square root of 74. Magnitude of vector B is square root of bx square 36, by square 100, bz square 81, which is square root of 217. Now we can calculate cosine inverse of the dot product of the two vectors divided by the product of the magnitudes. That would be cosine inverse of the dot product is minus 124 divided by the product square root 74 times square root 217. And this becomes 168.11 degrees. Now note that this is if this is an angle theta, cosine of the angle is negative, and we see that this angle between the two vectors has to be between 90 degrees and 270 degrees, since we see the requirement that cosine theta must be negative. Okay, after noting this, let's look at the angle found by considering the cross product. So if I look at the cross product of A and B, I will be using this determinant again. Well, how do I calculate A cross B? This is the determinant So first I have the unit vectors I hat, j hat, k hat. Then I have ax, which is minus 3, ay is 7, az is minus 4, minus 3 I had 7 j hat minus 4 k hat. Then I have 6, minus 10, and 9 for the components of vector b. 6 I hat minus 10 j hat plus 9 k hat. So this is going to be, let's start with, again, I hat. So I will be crossing the first row and the first column. And then I will look at the product of 7 and 9. 7 times 9 minus 4 times minus 10. So this will be the first one. The second one is minus j hat. So let me note here, this is plus, this is minus, this is plus. Then I have to cross the second row and second column. Then I will be left with minus j hat times minus 3 times 9 minus 4 times 6. Then I have for k hat, I cross the first row and the third column. Then I will be left with k hat times minus 3 times minus 10 minus 6 times 7. So this will give us I hat times 7 times 9 is 63, minus 4 times minus 10 is 40, so it's minus 40, minus j hat times minus 3 times 9 is minus 27, Minus 4 times 6 is minus 24. Another minus sign becomes plus 24. Plus k hat times minus 3 times minus 10 is 30 minus 42. So I see that A cross B is 23 I hat, 63 minus 40, plus 3 j hat minus 27 plus 24 is minus 3, minus minus becomes plus, and 30 minus 42 gives me minus 12 k hat. Next, I have to calculate the magnitude of A cross B. The magnitude of A cross B is square root 23 square 9 144 12 square. So this is basically roughly 26.12. Now I have to calculate sine inverse of magnitude of A cross B divided by AB. This is sine inverse of 26.12 divided by square root of 74 times square root of 217. This is what I have found for magnitudes. And the answer is 11.89 degrees. Now I note that since sine of pi minus theta is sine pi cosine theta minus cosine pi sine theta, and sine pi is 0, cosine pi is minus 1, this is equal to sine theta. Therefore, I see that sine inverse of magnitude of A cross B divided by AB can be written as 11.89 degrees or 180 minus 11.89, which is 168.11 degrees. So it's not clear which one we should pick, but in doing the dot product, since I have seen that the angle has to be between 90 and 270 degrees because the cosine has to be negative, I have to pick this answer. Okay, so the end result is that, well, both of these calculations give the angle between the two vectors. But since sine inverse of magnitude of A cross B divided by AB is always going to be greater or equal to 0 because I have a magnitude here, absolute value gives me positive quantity divided by AB is positive, and since I have magnitude of A cross B divided by AB is always going to be positive. So this is going to be a positive quantity. So sine theta, if this is angle theta here, sine theta is going to come out to be positive. So it is preferable, and that's why we have this ambiguity about this angle. This is basically telling us that the theta is in between 0 and 180 degrees. On the other hand, the other calculation gave us an angle between 90 and 270 degrees for the dot product. Therefore, we see that it is preferable to use the dot product to find the angle. Well, first of all, the calculation is a lot simpler, and second, we have a pretty good idea about the range where we should take this angle to be. Okay. Now let's move on to the next example. If the magnitude of A cross B is equal to the dot product of A and B, what is the angle between the two vectors? Well, the magnitude of A cross B is magnitude of A, magnitude of B, sine of the angle between them. But the dot product of A and B is magnitude of A, magnitude of B, cosine of the angle between them. So if these two are equal, AB sine theta is equal to AB cosine theta, we find that tangent theta is 1, and we know that this implies theta is equal to 45 degrees or pi over 4 radians. This would be our conclusion. Okay, so we have solved some examples on the cross product. First of all, we went through the procedure knowing the components of the two vectors on x, y, and z axes. We built this determinant. I had j hat, k hat, first vectors x, y, and z components, second vectors x, y, and z components, and we take this determinant for convenience with respect to the first row, and that gives us the answer. Then we have calculated the angle between two vectors using both the dot product and the cross product, and we see that the dot product is preferable because it's easier to calculate. You don't have to calculate a determinant, and also the sine of the angle is going to come out always positive, so it will be between 0 and 180 degrees. But if you look at the dot product, you get a better idea about which angle to pick, since we have sine pi minus theta is equal to sine theta. So it's preferable to use the dot product, but they both give the angle between the two vectors. And also we have seen that if the cross product magnitude and dot product are the same, then we have 45 degrees angle between the two vectors. Now, finally, I want to start a review of a differential calculus. And we will continue with this in the next lecture, because we will need this in the rest of our discussion. Now, suppose that y of x is a function that relates x to y, so it is a continuous and smoothly varying function of x. For example, it could be ax cubed plus bx squared plus cx plus d. So if I plot this function, y as a function of x, it's a smoothly varying continuous function. I see that x1 value corresponds to y1 and x2 corresponds to y2. And if I change from x1 to x2, there's delta x, that corresponds to a change in y, y2 minus y1, which is delta y. Now, how do I define the derivative of this function y with respect to x? It is the limit as this delta x goes to 0. We look at the slope delta y over delta x. So it's the limit as delta x goes to 0, y of x plus delta x minus y of x over delta x. So you can see here that x1 is what I call x, and x2 is basically x plus delta x. Then you will have a y of x here. This is y of x, and this becomes y of x plus delta x. All right. So let's look at some examples. Well, this is just a review. This is something you already know. If you look at the derivative of a constant a, it has to be 0. The derivative of a times x to the power n, it's n a x to the power n minus 1. Derivative of an exponential ax is a times e to the ax. Derivative of sine of ax is a cosine ax. Derivative of cosine ax with respect to x is minus a sine ax. Derivative of tangent is a secant square ax. Derivative of cotangent is minus a cosecant square ax. And derivative of natural logarithm of ax is 1 over x, because you get a over ax, etc. So you have to know by heart the derivatives of these functions in order to do calculations easily in the upcoming lectures.